It's the June 2014 question on pulleys and friction. So, two objects connected by a light inextensible string passing over a smooth light pulley. It's fixed at the bottom of a rough plane, inclining an angle of theta to the horizontal, where tan of theta is 3/4. A of mass 7 and B of mass 3. The coefficient of friction is 0.6. So here's our diagram here. Initially the objects are held at rest, the objects are then released. A slides down the plane. Find the magnitude of friction acting on A. So what I would start by doing is labelling up my diagram. So we've got object A of mass 7, so this is going to have a weight coming down of 7g by gravity. B is going to have a weight of 3 and g because of gravity. Now then, on the strings, we're going to have tension. So we have tension coming away from the object each time. We're also going to have a reaction perpendicular to the plane there. And we're going to have, because the object is moving down the plane, we're going to have friction coming back here. Okay. So looking at this diagram then, we also need to resolve each of the forces. So this 7g needs to be resolved perpendicular and it needs to be resolved parallel. Now it's going to go down the plane when it's parallel. So resolving this, two key points that we need to remember. Okay, when it is perpendicular to the plane, we use cos, and parallel, we use sine. So we're going to do 7g, it's perpendicular at right angles to the plane, so 7g cos of the angle, and then this 7g is also going to be parallel here, and it'll be 7g sine of the angle because it's parallel. Okay, I think we resolved everything we need to there. Let's check. Yep. Okay, so we're trying to find the frictional force. So the formula we're going to need for that is friction equals mu r. Now we already know what mu is. It's 0.6. But we don't know what r is at the moment. So we can put mu in. So the aim is to find r. Now to find r, I'm going to resolve perpendicular. So it's not going up and down the plane like this. So forces up equal forces down. So forces up is r, forces down are 7g cos of theta, or not theta, the angle. Now we need to find out what this angle is. Now we've been told that tan of the angle is 3/4. So do tan to the -1, 3/4, or 0.75. That tells us that the angle is 36.9 degrees. So we can put in the angle here. Work that out and we get 54.9. Then we can go back to this formula and replace r, so we should call it FR really, is 0.6 times by r, which gives us 32.9 newtons, and that is the frictional force. Okay, part B then, so find the magnitude or the size of the acceleration and the tension in the string. Okay, so as soon as I start seeing the word acceleration, I should be thinking of the formula. F equals ma, Newton's law of motion. Now then, this F here isn't friction, it's a resultant force. So force is pulling it forward, take away the forces holding it back. So, what forces have we got the object moving it forward? We've got tension, and we've got the 7g sine of the angle. So the forces forward, we've got tension and 7g sine of the angle, which is 36.9. Take away the forces holding it back. Now the forces holding it back is friction, that's the only one. And that equals the mass. Now we're focusing on object well, I didn't say actually, sorry. At the moment, we're just focusing on object A here because these are the forces to do with object A. I should have said that, sorry. So the mass of object A is 7, and we don't know what the acceleration is. Okay, so work out what you can from here. We know what friction is, so we can put friction in, which we knew to be 32.9. So let's work all this out. 7g sine of 36.9 is going to give us 41.19. Take away friction equals 7a. So collecting this up, that gives us 8.29 equals 7a. That's our first equation. Now we're going to do F equals ma for B, for object B. So looking at object B, forces pulling it forward is 3g, forces holding it back is t. So we have 3g take away t equals the mass, which is 3, times acceleration. Okay, so if we look at these two forces, these two ones, then we can work out what 3g is first of all. It's going to give us 29.4 take away t equals 3a. There's our equation 2. If we look at our equation 1 and equation 2, going to be simultaneous again. The bit that's the same as the t, different signs, so we're going to add. So the t's cancel out, add these two bits up, is going to give us 37.69. 7a plus 3a gives us 10a. Divide by 10, so a gives us 3.77 meters per second to the negative 2 there. Okay, so we found out what a is. Now we need to find out what t is. Paper. So we've got a. What I would do then is go back up to one of the equations, so this one here, and replace a to find out what t is. So I'll use equation 2. So 3g take away t equals 3 times a. Move the t over, move this over here. So t, move that over here, move this one over this side. So t equals 18.0